Hi students, now we are going to explain the phenomenon of refraction of light through a prism. Okay, in the previous topic we have studied the refraction of light through a rectangular glass slab. Now what is a prism? Let us all see a prism. This is a triangular prism. So this prism is having totally 5 surfaces. So one triangular and opposite also is triangular. These two faces are triangular faces, and remaining 3 faces are square type. Okay, square faces 1, 2 and 3. So these 3 surfaces which are square shaped are called lateral surfaces, and these triangular surfaces are called as base. So we will have to place the prism on any surface like this. Okay, keeping the triangular surface as the base, we have to place the prism. That is why these 2 triangular surfaces are called the base of the prism, and the remaining 3 lateral faces are there. Out of these 3 lateral faces, an experimental prism, I will show you an experimental prism which is very small like this. So the top and the bottom triangular faces, okay, we generally call them as a base to fix the prism in the spectrometer. One instrument is there. So like this we will have to fix the prism and rotate. Now out of these 3 lateral faces of the prism, 2 are polished. You can see that this is a polished surface. Okay, it is a polished surface, and another polished surface. Okay, another polished surface is like this. So 1 and 2, these are the 2 polished surfaces. Whereas the third surface, can you see, it is oily, it is translucent, it is a rough surface. So it is the grounded surface of the prism, which is not refracting. It is a non-refracting surface. While the other 2 surfaces, polished surfaces, these 2 polished surfaces are refracting faces of the prism. So first everyone must know that a prism has 5 surfaces, and out of these 5 surfaces, 2 are triangular. These 2 are triangular opposite, which are used to hold the prism just like this. Okay, to hold the prism. And the remaining 3 lateral surfaces are square shape, and they are called the faces of the prism. Out of the 3 remaining faces, 2 are polished, 1 is rough surface. So the 2 polished surfaces are called the refracting faces of the prism. Refracting faces. Okay, so that the third one is a non-refracting face of the grounded face of the prism. It does not refract light. So when light enters through the third phase, it does not undergo refraction. While when the light enters through the other 2 polished surfaces, then it will undergo refraction. Okay. Now can you all see that this is one polished surface and this is the opposite. Okay, polished surface. These 2 polished surfaces are meeting at this edge. So this is the edge, okay, at which this refracting face and this refracting face are meeting. So this edge is called the refracting edge. And if you look at the prism towards you, you can see a triangular cross section, isn't that? So that this left side is one refracting face and this right side, that is another refracting face. So this I have drawn on the board. So this is the cross section of the prism. Can you all see that it is drawn on the board? Triangular. So this is one face, okay, one face, refracting face, and this is another refracting face. So that can you all see one angle is made? Can you all see this angle made between the 2 refracting faces? This is the angle. This angle is called as the refracting angle. So this angle, okay, this angle is called the refracting angle. Okay, students. So I will name the prism as A, B, C. This is the triangular cross section of the prism. When I look the prism like this, okay, triangular cross section. Okay, A, B, C is the prism, and this angle also is named as A only. Capital A is a symbol for the angle of the prism. So what do you mean by angle of the prism? Angle of the prism is defined as the angle between the 2 refracting faces. between the two refracting phases, what angle is included? No, that angle only is called the refracting angle of the prism. Normally, for such prisms in the physics lab, can you all see it appears like an equilateral triangle? Does it appear like an equilateral triangle or not? See, any experimental prism will be mostly, okay, for refracting prisms, it will be equilateral triangle. There are some other prisms called reflecting prisms. 90-degree will be there, but this is refracting prism. So its angle is 60-degree actually. This angle of the prism, the refracting angle of the prism will be 60-degree exactly. Okay. So now you see here, I am sending a ray of light. A ray of light is incident on one refracting face of the prism. So what type of light I am going to consider is red color. This is red color light. Red is one of the colors in the VIBGR. So red color. So I am using the red color light. Can you all see that red light on the board? So red is having a certain wavelength. Among all colors in VIBGR, red is having the longest wavelength and violet is having the shortest wavelength. So red color light is called as monochromatic light. Whereas white light we have already studied is a combination of several colors. So it is called as what? Polychromatic light. White light is called as polychromatic light. But I am going to use for the study of refraction, we have to use only monochromatic light. We cannot use white light for this study of refraction. So I am using a red color LED laser. It is called LED. Light emitting diode is used to produce a laser beam in this. So it is called laser LED source, which is a source of monochromatic light which emits red color. You can see that it is a red color light. Okay, red light is passing through a straight line. Light travels along a straight line. Okay, now you see that I have taken the prism. So this is one refracting phase. This is another refracting phase, and this angle is called angle of the prism. I keep the prism and I will send the light through the prism so that it refracts the light. And the outcoming light, emerging light, you are going to look at the board now. First, without the prism, can you all see the spot of light over there? Is it visible? Good. Now I am going to introduce this prism on this path of light. On the path of light, when I place the refracting face of the prism, this spot of light will be displaced this side. From here, it will turn inside the prism. When the red light travels, it will bend, it will turn, rotate, and it will fall at some other point. So this spot of light, what you are seeing, is called incident light. It is an incident ray. You see here, this is the incident ray. And now when I place the prism, okay, but I am going to place the prism. All of you see that I am introducing the prism now on the path of light. Can you all see that there is a shift in the path? Can you see that this red spot is shifted here? You see here, the moment I introduce the prism, a red color spot will appear here. You observe that red spot, so that the light will turn beautifully. Okay, you see here. Can you all see? Yes. Can you see the difference? See, this is the incident spot of light. So when I introduce the prism, the spot of light appears somewhere else. So if you draw a straight line connecting this spot with this source, that is the ray, is called as incident ray. And when I introduce the prism, the spot is appearing below that initial C. So the distance between the two positions of the spot you find out. Now if you draw a straight line from this refracted image and this source, two straight lines can be drawn. The angle between these two only is called as the angle of deviation. The light is deviating inside the prism. Very simple. I hope you must have understood this. Shall we go to the topic now? Okay. So this bending of light inside the prism, okay, due to the difference in the optical density between air and the glass. This is only called as refraction of light through a prism. Now I will take this incident ray is named as PQ. So PQ is the incident ray. It falls on the prism at this point Q. So this is the normal which is drawn. Okay, normal is a straight line drawn perpendicular to the refracting surface. So AB is the refracting surface. Now the light travels from air, okay, from air inside glass. and the surface of separation is now AB. So above AB the medium is air, and below AB the medium is glass. So comparing air and glass, air is the rarer medium and glass is the denser medium. So that when the light enters from air to glass, it does not travel along the same straight line like this. It does not travel along the same straight line. So it bends along a QR. It bends along a QR. Can you all see this QR? QR is now called as the refracted ray. Refracted ray. Okay. So this is the angle of incidence. Angle of incidence for the first surface AB. So I1 I have taken. So this angle is I1. And this angle can be taken as R1. Understand? R1. Similarly, now the light traveling along QR has to come out of the glass prism into air again. Once again, it is coming from glass to air, from a denser medium to a rarer medium. So second time refraction is going to take place. So the second time refraction is going to take place at what surface? AC. Is it not? So for that, this will be the angle of incidence and this will be the final angle of emergence. So this is the final angle of emergence. I will take E. E is the angle of emergence. So this is another normal I will take. Okay, it is a M I will take. Okay, M. So that here N is the normal, here M is the normal. Now the ray is bending away from the normal and it travels along the direction RS. So in the total picture, in the prism, how many times the refraction is taking place? 2 times. Is it not? Twice. Once the refraction is taking place at the surface AB when light travels from air to glass, and the incident ray is PQ and the refracted ray is QR. For the second time, refraction is taking place at what surface? AC. That is, light travels from glass into air itself once again. So glass to air. So now the light is bending along the direction RS. Okay. So that RS is the finally emergent ray. Finally coming out ray is called as the emergent ray. Now, if the prism were not placed at this place, not placed here, the light should not have bent. The light should have traveled along this straight line which is produced. So I will take this point, okay, this point as a H, and I will produce this straight line here. Can you all see? I am producing this. So you can see that this point is taken as G. I will take this point as G. Now I have extended the incident ray PQ up to G up to H. So the incident ray is stretched up to H. That is the direction of the incident ray. And I have produced in the reverse direction the emergent ray up to G. Can you all see here one angle? Here one angle. Can you all see? That is the angle between the two rays. One is the direction of the incident ray produced. The other one is the direction of the emergent ray. If the prism were not placed here, the light should not have bent and it should have traveled along the direction what GH. Because the prism is placed, the light inside the prism has turned and once again it is coming out along the direction RS. So this angle H, G, S, or H, G, R. This angle is denoted as angle of deviation. Angle of deviation. That is very important here. So the light has deviated from its original direction by a certain angle. This only is called as angle of deviation. And what type of light we have used here? Red color light. So it is having a single color, it is having a single wavelength, it has a single frequency, and hence this light is called as what? Monochromatic or monochromatic light. Monochromatic light. And which color we have chosen? For example, in this experiment is a red color light we have used. Okay. And here this is the angle of incidence, and PQ is now called as what? Incident ray. Okay. This is the incident ray. And QR is called the refracted ray. That refracted ray for the first surface. But QR is also the incident ray for the second refraction. Is it not? And RS is the finally emergent ray. RS is called the finally emergent ray. Emergent ray. So the angle between the incident ray produced and the emergent ray, this is called as angle of deviation. So capital D represents the angle of deviation. This represents the angle of deviation. And capital A, this angle A represents the refracting angle of the prism. The refracting angle of the prism. Now, there is one activity, one small activity or experiment is there to trace the emergent ray using the alpin. Okay, we are going to use the alpins. So for that, what we are going to do is, we take a sheet, okay, we take a sheet of paper, a white sheet of paper, which is fixed on the drawing board using drawing board pin. Drawing board pin is there, no? We have to fix a sheet of white paper on a drawing board, and we have to keep this prism. So like this prism you have to take, and you will have to keep the prism on the white sheet of paper, and you have to draw the boundary. If you draw the boundary, what shape do we get on the paper? It is a triangle. Okay, so I draw the boundary of the prism like this. Okay, on the paper like this I will place, and you will get a triangular picture like this. Boundary. So I place the prism on the paper, I draw the boundary like this, and I will remove it. I will remove this. Okay, then I will draw the normal to one surface. So I will note down that this is A, B and C. At any point I will roughly draw one normal. Okay, this is the normal 90 degree. So in this activity we will take a pencil and draw the normal. Then using a protractor, okay, using a protractor you can choose any angle of incidence. You can choose any angle of incidence. So roughly I will take one incident ray. So this is one incident ray like this. After drawing the incident ray, after drawing this incident ray, I will take two alpins. Small pins will be there, is it not? That pins. So I will mark 2 points like this. I will mark 2 points which are separated by 4 or 5 centimeters. 4 to 5 centimeters at least minimum separation between 2 points. And I will note down the points as P and Q, the 2 points. Then at this point I will fix one pin, and along the same straight line I will fix another pin. Are you all understanding? 2 pins I have fixed, okay, vertically, one behind the other. So 2 pins will be like this. 2 pins I have fixed, so that one pin will be exactly behind the other along the same straight line. Okay, then what I am going to do is, I will go to the other side of the prism, the other side, okay, the other face, refracting face of the prism, and I will see through this other face. I will see through the other face. So do I see the image of the 2 pins or not? The image of the 2 pins which we have fixed on the left side will be visible from the right side. So I observe the image of the 2 pins on the other side, and take 2 more pins. I take 2 more alpins, and I will just observe the image of the 2 pins along the same straight line. I will fix 2 more pins like this. I will fix 2 more pins such that all the 4 pins are in the same straight line. Understand? So by observing, see here I am observing like this. So 2 pins were fixed on one surface, one refracting face. From the other face I am viewing the images of the 2 pins. Along the same straight line I fix the 3rd pin. and then the fourth pin, such that the two pins on the right side and the image of the two pins on the left side of the prism all will lie along the same straight line. Understand? So I will fix two more pins like this, and I will note down the points. Let these points be R and S on the other side. So at this point I have fixed one pin, and here another pin. Understand? So now I will take a scale and I will join these 2 points. I will extend up to the prism. Understand? I will extend up to the prism like this. And then I will join these 2 points also. These 2 points. So along PQ, the light travels to the prism at AB. Then it undergoes refraction at AB. It travels along some other direction. Say for example, these 2 points are E and F. Then after that it is traveling from R to S along this direction. So this type of experimental activity you must have done in the class and enjoyed it. So this is an experiment to demonstrate that the light undergoes refraction twice. One at the surface AB and next at the surface AC. So what is the total angle of deviation? I told you it is the angle between the direction of the incident ray and the direction of the emergent ray. I hope you must have understood what is meant by refraction of light through a prism, and also I hope you must have understood this small activity to trace the path of the emergent ray. Understand? Suppose if you want to measure the angle of deviation, means you will have to produce this incident ray. So you will have to produce the incident ray along this straight line like this, and you will have to produce this backward. Then if you measure this angle, means you can measure the angle of deviation. So first you take a particular angle of incidence I is equal to 30 degree and find out what is the deviation. Then I is equal to 45 degree. Then I is equal to 60 degree. Like that, for 3 different values of angles of incidence, you measure the angle of deviation. The angle of deviation will not be the same for all the angles of incidence. Understand? One more high level point you learn now itself. See, inside the prism like this, if the ray of light is incident at different angles of incidence like this. These are all different angles of incidence. This is the normal, okay? This is the normal. You see here one angle of incidence, this is 2 and 3. Can you see here angle of incidence is less, here in between value and here greater value? Now, corresponding to each incident ray here, you will have three different refracted rays. And 3 emergent rays you will be having like this for 3 different angles of incidence. And you will see that for one particular angle of incidence, the refracted ray will travel parallel to the base of the prism. Can you see that this line and the 3 lines are not parallel to the base of the prism, is it not? But this 4th line which I have drawn is approximately exactly parallel to the base of the prism, is it not? So for that one corresponding emergent ray will be there, is it not? So this will have the minimum value of angle of deviation. The angle of deviation will be minimum for only one particular angle of incidence, is it not? So that you will study in the higher level. Anyhow, deviation is defined as the angle between the direction of the incident ray and the emergent ray. Okay, fine students.